I go on the morning run.
Who can tell me, how far do you run?
Huh? Like a mile.
I run like a 5K.
No, you don't.
It's conditioning.
Who can tell me what it means to be similar? Similar figures, what does that mean? Present. Not quite the same, but how are they similar? How are they the same?
Same.
Ooh, like the same angle. Okay. Do they have the same number of sides? Okay, so could we say that they have, oh my, the same shape, but different size? Oh, what did you say? Yes, you did.
Dilation.
Like a dilation. Okay, when we did dilations, back in the chapter where everyone got an A. Uh-huh.
Supposed to be.
Wow.
Those were similar figures. They had, like you said, the same angles, measurements. They had the same number of sides. One was just stretched or shrunk compared to the other. Okay, so what we are going to do throughout this chapter, we're going to start with just like similar. We're going to start with similar figures in general. Thank you for your help, but I got it. Starting tomorrow, we're going to work specifically on similar triangles. Okay, now with our corresponding parts, we know that corresponding angles are going to be congruent, like Nora said. Our angles are going to be the same. Okay. However, our corresponding sides are not going to be the same. How would we describe our corresponding sides? What makes them similar?
Same shape, different size.
Okay, the word starts with a P.
Parallel.
Really?
Perpendicular.
No.
Let me think.
Brain, you have a brain.
Oh, good job looking at the
How do you
page.
even- That's not even a word.
It's right here.
Oh, thank
Oh
you.
my gosh. We're supposed to look at
Man.
Who can tell me what proportional means?
They're the same size.
What's a proportion?
Like
Hmm.
it's like something divided like
The
this. Like something
size
divided
of
like
it
into different
is
each
equally.
I don't know.
Divided up.
Presley?
like that's like.
Okay.
Is it
Same
like
here.
a certain
True
type
that.
of size?
It's a certain type of size. So how about I do this? You don't have to. Okay. 2, 3. These are similar triangles.
Yeah.
They could be divided or multiplied by. A
Oh, it's
certain-
multiplied by 3.
Okay, so what is this side right here? 9, and what would this side be?
12.
Okay, so what we say proportional means when we take the ratios of our sides, they're always going to be the same ratio. Okay, why are you using an expo marker on paper?
Wait, is that dilation?
Well, so I couldn't find a pencil.
You want a pencil?
And then halfway through looking through a pencil, I was like, oh, it's the first day back. Probably don't need a pencil. Because like usually we don't do stuff. So I don't have
You're
a
in the
pencil.
soft.
Sam, you would never make this mistake if you played
You what?
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 in D&D, you always have a pencil.
I'm not
They
trying to
teach you
start
that.
off.
Okay, so when we have similar figures, we know that our corresponding angles are going to be the same, but then our sides are gonna be proportional. So we can take AB and DE, and when we make that ratio, it's gonna be the same as all of the other ratios that we put together. Okay, so we're gonna draw a picture that way, like we actually go through the process of naming all these things. Okay, so we are going to draw a trapezoid ABCD, and it's going to be similar. This squiggle right here, it looks like the top of a congruent sign. Without the equal, it means similar. Okay, so that squiggle means similar. And to write that down.
Tom, did you see the two screen?
I did.
It's the Bengals.
I did. Finally got that W. The game on Christmas Day was, they are in the playoffs. Yep, how do you feel about that? Okay, so Ben, angle A is congruent to which angle?
Angle. Is her name
Thank you, Ben. Hey. Clark, what about angle B?
Angle B is X.
Angle B and angle X are congruent. Sam, name me two congruent angles.
C.
Y.
Okay, and then D and Z are congruent. Okay, since these two trapezoids are similar, then their corresponding angles are congruent. Now, keep in mind that, you know, A and W are going to correspond. They're in the same place, both in the picture and in how we name our figures. Okay, so that's going to be important as we move through, especially our triangle stuff. We have to match up the corresponding pieces together. Okay, now, since these are not congruent, but they are similar, then the ratio of our sides will be the same no matter which pair of sides we pick. So if I choose side AB, its corresponding side would be, what corresponds with AB? WX. So if I take those measurements and I make them into a ratio, it is going to be the same ratio as if I take BC's measurement over XY's measurement, which will be the same as CD over YZ, which will be the same as AD over WX. I mean WZ, excuse me. I know my letters, I promise. This is what we call the statement of proportionality. That's a fun word to spell. Okay, so we need to be able to do a couple different things. We need to be able to, A, find a missing side of two similar figures. B, we need to be able to determine if two figures are similar. So we're gonna do each of those things on the next page. So right here, where it says notes, I want you to draw a trapezoid A, B, C, D. Oh, I guess we're not finding. So I got a little ahead of myself. I guess we're really only looking at scale factors and if we have similar figures. Oh, no, we get to do both. Okay. Sorry. We're gonna just pretend that that looks fine. Okay, so let's talk about the scale factor. Okay, now we can talk about the scale factor from ABCD to XYZ, WXYZ and back and forth. So if we are going from trapezoid ABCD to trapezoid WXYZ. Okay, let's just pick one pair of corresponding sides. These right here. What's the scale factor from ABCD to WXYZ? So I can multiply all of those sides by 4 to get WXYZ?
Yeah.
Seriously?
The water bottle.
Okay, it would actually be 1/4. 16 times 1/4 gets me 4. 12 times 1/4 gets me 3. 8 times 1/4 gets me 2. The scale factor from trapezoid WXYZ to ABCD, that would be 4, because we would have to multiply by 4 to get from WXYZ to ABCD. Does that make sense? Chris, are you good? Okay. Now, I'm going to draw 2 triangles. I don't know.
Figure out one of the sides that corresponds.
So let's talk about the Pythagorean theorem. When's the only time we can use it? Okay. So if we have a right triangle, yeah, or a leg, then we could use it. But are either of these right triangles right now? Okay, so we have 2 stipulations if we have similar figures. Number 1, our angles are congruent, our corresponding angles are congruent. Number 2, our sides are proportional. So number 1, are the corresponding angles congruent? We have to do a little bit of math, scary. What's the measure of angle A? 73 degrees, that's what's left over from 180. Okay, what about angle L? Okay, so let me ask this, are the corresponding angles congruent? Okay, so our corresponding angles are congruent. Now we need to check to see if we're proportional. Now, we got to be careful and make sure we match up numbers correctly. So what does 8 correspond with? 4, how do you know that?
73 and 40.
Because you're looking at the angles, okay? So what about 4? So 8 over 4, 4 over 2, and 12 over 6. Do those all equal the same thing? When we reduce those down, those are all 2. Okay, so yes, these are similar. Okay. Now what's really cool, I know you think it's cool, about similar polygons is that whatever the ratio of the sides is, that will also be the ratio of their perimeter. Okay, so I don't have to know an entire perimeter, sorry, to know the other one. So like, let's say in this picture, I want you to label KL as 10 and PQ as 15. Okay, so the ratio of our sides would be, it's like our scale factor, we could say is 10 over 15, right? Which is what? Let's keep it in, what? Okay, so I see where you're going. If we're talking about, okay, because you were looking at over here, let's be consistent with that. So they have PQ over KL. So you in your mind were saying 15 over 10, which is yes, 1.5, but we're not writing it as 1.5. What are we writing it as? Nope, still not. A ratio is just one fraction, 3 over 2. Okay, so our scale factor is 3 over 2. Okay, which means the ratio of our perimeter, okay, this means ratio of is also 3 over 2. Okay. How is that helpful? I'm gonna just start making some things up, okay? 4, 8. Making those numbers up, okay? What's the perimeter of KL and M? Huh? 32, do you agree? Okay, so what we can do is we can say, all right, I don't know what the perimeter is of PQRS, but I do know that the perimeter of KLMN is 32. And I know our scale factor is 3/2. So we can set up a proportion, and instead of solving for these 3 sides, we can just say, oh, hey, I can figure out my perimeter this way. What is the perimeter? What? Same thing, but now with area. We can take a scale factor, so let's go back to this being 10 and 15. We know that our scale factor is 3/2. So when we talk about the ratio of the area, it's that same scale factor, but squared. That makes sense, area. We talk about square units. Okay, so the ratio of our area is 9:4, since our scale factor is 3:2. All right. So that's what we're gonna do. We're gonna go to that next page. We're gonna look at a couple examples. Okay. And number 2, we need to find X. What do we do? We know that these two triangles are similar. What do we need to do?
I mean, to more visualize it correctly, we could do a rotation and match all of the sides. And then we could figure out, which the dilation is, because that is dilated down or up depending on which is
Okay.
which. And if we need to go down, by flipping to the side, it's 30 and 12 together, 8 and 20 together, and 20 and X, 25 and X together.
So 25 and X go together, right? Okay, and what's another pair that goes together? 12 and 30. Okay, so I'm gonna take what you said, Clark, and we're gonna make it a little bit simpler. So Clark said, hey, we can figure out what our scale factor is. Okay, well, we know that 30 corresponds with 20, right? I mean 12. That's what I said. I said 12. So we can put 30 over 12. Right? Well, what does 30 over 12 have to be the same as? And what else? 25 over X. We know that all 3 of those have to be the same. Well, 20 over 8, we can use it, but really we only need 2 ratios to set equal to each other. And now how do we get X? Cross multiply, we can take 30 times X equals 12 times 25.
300.
300?
X equals 10.
So X.
Actually, go top side.
Oh, that's it.
Okay. You guys have never cross multiplied before?
Not really.
I did the butterfly method.
Yeah, the
That's,
butterfly method.
that's cross multiplying, and we don't call it the butterfly method, we call it cross multiply.
I don't remember
Are you
that.
serious? I mean,
6th grade.
we did in 7th grade. We did not.
No,
No,
we
we
didn't.
did.
We did not do
Why
it.
did Miss,
us.
why
No,
did
she
Miss
didn't.
Carroll
She
teach
did.
us that?
I don't think you do cross multiplying in algebra,
You don't.
It's just.
but you did it in 6th grade. I know you did it in 6th grade. Okay. Okay.
I was too busy in the excelling that group. Or the star group. I don't know what it's called.
Now you just sound a little,
We all got kicked out because we didn't put our names on the paper, so it just.
I was in the blue.
that sounds like a bad story. Okay, now let's talk about the scale factor. From ABCD to KLM and P. What is the scale factor from ABCDE to KLNP, whatever, that one. So let's pick 2 sides that correspond. I see AB right here and KL. So what's the scale factor to get from AB to KL?
1.5 or
3 over 2.
3 over 2. let's go backward. What's the scale factor from KLMNP to ABCDE?
Thirds.
Okay, we're putting those numbers over each other and we're simplifying. Okay, now let's talk about the perimeter. Okay, so let's just go back to this one right here. Our scale factor is 3/2. What's the ratio of the perimeters? The same, people. It's the same. 3/2. Okay, it's the same. Whatever the scale factor is, the ratio of the perimeters is the same, but the ratio of the areas is no squared. It is squared. You're making me feel some feelings today here, guys. Well, you kind of making me feel bad about myself. All right,
Really, guys?
so you have pages 1 and 2 from your. Okay.
No, man.